Numerical methods are used to help us take facility location decisions. In this video, we will review three very simple methods. These methods are called the factor score or the weighted score method, the load distance method, and third, the centroid method. We will look at each of these methods one by one. First, the factor score method. The factor score method is used when there is not just one factor or criterion, but multiple factors or criteria that matter to a location decision. In some cases, the distance or time may not be important. In such cases, the factor score method can be very useful. Let's take a simple example. There is a clinic called Arogya Srishti, and it is assessing three places in Chhattisgarh, Raipur, Bhilai, and Korba for setting up its next clinic. The following table shows the three locations and their ratings along various factors that are important to the decision. As you can see in this table, factors such as proximity to patients, facility location, the average time per emergency trip, the accessibility to an expressway, the costs of land or construction, and the preferences of employees. These six factors are listed. There could be other factors too, but these six are considered important here. Each factor carries a weight. So the person doing this evaluation gives a weight to each factor in such a way that the total of the weights comes to 100. As you can see here, proximity to patients is given a weight of 25. The facility's expected utilization is given a weight of 20, and so on. And then scale, for example, a Likert type scale is used to assess each of the identified locations on each factor. So you can see here Korba, Bhilai, and Raipur, all three have been evaluated on a Likert scale ranging from 1 to 5, where 1 means poor and 5 means excellent. So how do we apply the factor score method with all this information? So what we do is we compute a weighted score for each proposed location. For example, the weighted score for Korba is the score that Korba is given on the first factor multiplied by the weight of that factor plus the score that Korba is given on the second factor multiplied by the weight given to that factor, and so on. In other words, the score that Korba gets is a weighted score of the ratings it has got on the different factors along the scale multiplied by their respective weights. So for Korba, the score would be 25 into 4 plus 20 into 3 plus 20 into 3 plus 15 into 4 plus 10 into 1 plus 10 into 4. So we have taken the weight obtained, weight given to each factor and multiplied it by the score obtained by Korba on that factor, and then added up the product terms along all the factors. Ultimately, Korba gets a score of 330. In the same way, Bhilai gets a score of 310 and Raipur gets a score of 320. As we can see, Korba has got the highest score, 330. And therefore, we would like to pick Korba as our desired location because Korba performed best on this weighted score. You can, however, see that the different locations perform differently on the different factors. And it's for this reason that we are not able to resolve unilaterally that one factor is the best. No single factor is unilaterally the best. Each factor performs well on certain dimensions and not so well on other dimensions. And that is where a weighted score becomes useful for us to decide which factor to pick or which location to pick, I beg your pardon. And that is why the weighted score method helps us to pick one location as the best. The next method that we will look at is the centroid method. In the centroid method, the decision maker wants to identify a location that can be termed as some kind of a center of multiple existing locations. So there may be no pre-identified points for the new location to choose from. There's an open canvas, a geographical region, and the new location can be anywhere on this region. Here, the centrality is more important than the actual distance between the new location and the existing locations. So when centrality is a key factor, the centroid method, which is also sometimes called the center of gravity method, can be used. So how do we do this method? Let's look at an example. There is a supplier to a telecom industry which provides fuel for power generators. More than 600 tons are to be shipped from a warehouse to 8 major customer locations in and around a large city. So there are, you can see here in this example, there are 8 customer locations A, B, C, D, E, F, G, and H that have been identified. And the second column in this table gives us the quantity that should be shipped from the location of the warehouse. The warehouse is something whose location we have to find out, and the quantities to be shipped from that warehouse to these respective locations. These quantities are given here: 5, 92, 70, and so on, all in tons. And we are also given the X and Y coordinates of these customer locations. We need to find out the best warehouse location, the coordinates of the best location for the supplier to set up a warehouse. And it need not be one of these locations. It could be any location that is suitable to cater to these 8 locations. So going forward, you can see that we have plotted the customer locations on this graph. A, B, C, D, E, F, G, H, they come in these locations. So where should the warehouse location be? To identify the coordinates of the warehouse location, we apply the centroid method. The centroid method gives us the X and Y coordinates of the proposed location. So how do we compute these X and Y coordinates? The X coordinate is computed as the weighted average of the X coordinates of the 8 customer locations. So if we take the X coordinate of each customer location and then take the tons, the quantity to be shipped as the respective weights for these 8 locations, then a weighted average would be computed by this formula. The X star refers to the X coordinate of the proposed warehouse, is sigma over I of Wi xi. Wi is the weight given to customer location I, and xi is the X coordinate of customer location I. So sigma over I of Wi xi divided by the sum of the weights. So this is the weighted average of the X coordinates of the different customer locations. Exactly in the same way, we compute a weighted average of the Y coordinates of the customer locations to get the Y coordinate of the proposed warehouse. So the X star and the Y star that we computed in this manner are the proposed coordinates of the customer of the warehouse location. We should also note that what we refer to as weight, in this example, we have taken the quantity to be shipped as the weight, but it need not always be that. It could also be the number of employees working at these different locations. It could be the number of customers visiting that location in a given period. It could be the number of to and fro trips made in a period, and so on. We could obtain the new location to be 12.4 and 9.2. We should also note that it may not be possible to locate the facility exactly at 12.4 and 9.2, and hence we must find a location as close to this as possible. That could be a way to use the centroid method to find the location. Now, in our graph, the centroid that we identify would come somewhere here. If we examine it closely, we would see that it is somewhere around the points C, F, G, and D, and relatively farther away from the other locations. This could be because the weights of the other locations and their X coordinates were closer to a geographical center. So this is the centroid method. The third method that we will look at is the load distance method. In the load distance method, the distance or time is a primary criterion. So we select a location that maximizes the sum of the loads multiplied by the distance traveled or time traveled. Here, the word load can be any of these kind of things, like the quantity shipped or number of employees working at locations, number of customers visiting that location, number of to and fro trips made in a period, similar to the kind of criteria we had for weight centroid method. So similar to the way we computed the X and Y coordinates in the centroid method, we compute what is called as the load distance score for each location using this formula, the sigma over I of Li Dij. Dij stands for the distance between the existing locations and the proposed new location. So sigma over I of Li dij divided by sigma over I of Li. It is a weighted score. Here it's also called the normalized load distance score for location J, the proposed location J. Now, how do we compute the distance between two locations? There could be multiple methods. So let's take an example. The distance between these 2 points, 30, 15 and 60, 75 can be computed by the method of Euclidean distance. Euclidean distance is computed like this. The square root of the sum of the squares of the differences between the x and y coordinates of the two locations. For example, here we have points A and B. So within the square root, we have xa minus xb the whole square plus ya minus yb the whole square. The sum, the square root of this sum. This is the Euclidean distance between the 2 points. The rectilinear distance is different from the Euclidean distance. When we consider rectilinear distance, we are moving along a path which is parallel to either the x-axis or the y-axis. So the rectilinear distance between A and B would be the absolute value or the modulus of the distance between the x coordinate of A and B plus the modulus or the absolute value of the distance between the y coordinates of A and B. So absolute value of xa minus xb plus absolute value of ya minus yb. The sum of these two is the rectilinear distance between A and B. And finally, we could also take the distance by the best road available. It may not be possible to travel by along the Euclidean distance or the rectilinear distance along the two routes which represent those distances. And the best road available could be having a completely different distance. So in some problems, we may consider that distance itself. Let's take an example. A large IIT campus wants to set up a central photocopying facility for the benefit of its residents. And you can see that it's identified 3 potential locations in the campus, which are denoted here by P, Q, and R. And it is taking into account the existing facilities such as the students' hostels, computer center, central library, the faculty residences, the administrative block, the classroom complex, etc. as criteria to help us decide which among P, Q, and R is the best location for the photocopier center. So here we have a table which shows the different activity centers and the distances of P, Q, and R, the proposed or possible photocopying center locations, the distances of each of these locations from each of the activity centers. You can see here, for example, that location P is at 1.6 kilometers from the administrative block, 1.3 kilometers from the faculty residences, and so on. Similarly, location Q and location R, their distance is also given. We are also told from each of these activity centers how many trips or how many person trips do we expect to make to each of these locations, the photocopying center. So you can see here from the administrative block to the photocopying center, we expect 35 trips a day. From the faculty residences, we expect 5 trips a day. From the classroom complex, 15 trips a day, and so on. So these estimated average person trips are given in the last column. Now, what do we do with this information? We compute the load distance score for each location P, Q, and R. It would be computed in a simple way. For example, for location P, it would be 1.6 into 35 plus 1.3 into 5 plus 0.9 into 15 and so on. That whole sum divided by the sum of the person trips, 35 plus 5 plus 15 plus 30 plus 20 plus 55. So this weighted score, it is sigma Li dij divided by sigma Li gives us for location P 0.82, for location Q 0.47, and for location R 0.61. So which one should we take as the best? Naturally, the one with the lowest load distance score is the best location because that is relatively closest to all the activity centers, taking into account the number of trips made. So Q is the best location as per this calculation. It may sometimes happen that there is no set of options given to us beforehand for the new locations. As in this example, P, Q, and R were given to us as possible locations. But suppose we are not given that, we just have an open canvas and we are asked to find out what could be the best location. Could there be a location even better than P, Q, and R in that example? The answer is there is a possibility, and we can use a search heuristic. A heuristic is an optimization technique which can find us a good location better than what we might otherwise be able to find using our intuition or using a simple method like this. So a heuristic can help us to find an optimal location, that is where the distance is taken as either Euclidean distance or rectilinear distance. What would it look like? Let's take an example. Let's say that in the city of Chandigarh, here on the right side, we see a map of the city of Chandigarh. There are 5 retail outlets, and the coordinates of these outlets are known to us. The outlets are marked here 1, 2, 3, 4, and 5. Uh, a vendor has decided to rent a space in the city for warehousing his stock in order to be able to supply replenishments to any of these locations whenever required. So what is the ideal location for the warehouse? That's the question. So we can see that the roads in Chandigarh follow a grid layout, and therefore rectilinear distance may be useful here. This table gives us the locations, the X and Y coordinates of the 5 retail outlets, the demands experienced per month as units per month in these 5 locations. And we can apply a heuristic. I'm not going into the details of how this heuristic is to be applied, but I've applied the heuristic on Microsoft Excel. And Excel has an inbuilt solver with which we can run an optimization algorithm. So using the algorithm, the point 22, 15 gives the minimum load distance score. So if you go to the map, this point 22, 15 is right in the middle of a bird sanctuary in Chandigarh. Well, it may not be possible to set up a warehouse inside a bird sanctuary. So therefore, it may seem as if the point that we obtained was not useful, but actually this can help us to find a location which is somewhere near. So we might find a location which is not too far from this bird sanctuary and settle for that as a good location for our warehouse. So in this way, a search heuristic can be useful to us when we don't have predetermined locations. So the load distance method can be used when it is possible to list a set of options beforehand for a new location and compute the distances from each of them to the existing facilities. And it could also be used when there is no set of options available beforehand by using a heuristic. Apart from the 3 simple methods that we saw, there are also more advanced numerical techniques which are used often in location decisions. They are known by the broad term multi-criteria decision-making techniques. A large number of techniques are available, such as the analytic hierarchy process, the analytic network process, Demetel, and so on. There are many other methods too. So in this way, numerical techniques can be used to help us identify best location or at least a good location for setting up a new facility.